Negative I to the fourth is positive 1. And then that'll be 2 squared plus 3 times plus positive 1 times negative I 2 root 2, sorry, that's a 2, and then plus 4 times negative 1 times 2, right, yeah, minus, that should be plus 6I times root 2 plus 4 equals 0. So we have 2 squared is 4 plus 2 times 3 is 6. Oh, and then there's a minus out there, so I'm going to do minus 6I root 2. And this will be minus 8 and plus 6I root 2 and plus 4 equals 0. So we have these, the imaginary terms canceling, because we have a negative and a positive. They cancel out. And then we have 4 plus 4 is 8, so that cancels with the negative 8. So 0 equals 0. Yes! Yes!
Yes! Oh my god!
So, yes, this check was successful. And that's all you have to do for that. It says find the remaining root, use the theorem. So you're going to have to learn the theorem, learn what it means, remember it, and you can use it a lot. It's very easy to remember and very easy to use too. So that's my note. Remember the theorems. Remember the theorems. If you do that, these problems are so easy. Next example. That was example actually 12. Next one will be 13. 13! Okay. A root is given. These are the instructions. A root is given. Solve the equation. So we're going to have the equation being x minus 4 times, or minus 5x squared minus 10x minus 6 equals 0. The roots will be negative 1 plus I, which means if we use the theorem, what do we get? Negative 1 minus I as a root. So that means is a root. So we can use synthetic division to get a smaller equation that's of smaller degree, the depressed equation. So let's do this. Negative 1 plus I, and I can't forget my placeholders. That's the first thing I look for. So we have 4. We need a 3, 2, 1, 0. So we'll have 1, 0 minus 5. Negative 10, negative 6, that's it. So I bring down the 1, and I have negative 1 plus I, adding 0, so I have negative 1 plus I. And this kind of stuff I don't like to do in my head, so I'm just going to do it right over here. Negative 1 plus I times negative 1 plus I. That will be 1 minus I plus I squared, which will turn to minus 2I minus 1. So these go away. Choo, choo, gotcha. So when we multiply this out, we get minus 2I. So this times this goes up here. So we have minus 2I. Add these, they're not like terms, so I just write it down. Negative 5 minus 2I. and then I gotta multiply these out again. So I'm not doing it in my head. No way. I don't trust myself. Negative 1 plus I times negative 5 minus 2I. Negative 1 times negative 5 is 5. And then plus 2I minus 5I minus 2I squared, which changes to 5 minus 3I plus 2. So that's 7 minus 3I. Okay. So this times this gives us 7 minus 3I. Add that together and I get negative 3 minus 3I. And now I gotta multiply one more time. Negative 1 plus I times, what am I doing? Negative 3 minus 3I. That's 3 plus 3I minus 3I. Yay! Minus 3I squared, which means 3. Oh, this is gonna work out. Those go away. Plus 3, which is 6. So bring that up. We have 6. That means 0 as a remainder. That means, yeah, it is a root. We already knew it was a root. But now we can get our depressed equation. So this is the constant term, the x term, x squared, x cubed. So our new equation is 1x cubed minus, actually no, plus minus 1 plus I. Careful when you have two terms like this. You can't do minus and then 1 plus I, because the minus is only for this 1. If we wrote it on the outside, it would get distributed, and we don't want that. So this is the x squared term plus minus 5 minus 2 x minus 3 minus 3I. Okay, so that's our new equation. And for these problems, we have to do synthetic division twice because we have another root. This one was a root, but this one is 2. So let's do synthetic division with the other root. Let's do that. So we have negative 1 minus I for our synthetic division. I'm checking for placeholders. 3, 2, 1, 0. Okay, we're good. So that's a 1 minus 1 plus I. Negative 5 minus 2I. Negative 3 minus 3I. Those are my terms. 1 plus 1. Alright. Minus I, add that up, and I get negative 2, because those cancel. And then negative 2 times that is 2 plus 2I, which means these cancel out, so those cancel. These will cancel, so I get negative 3. And then negative 3 times this would be plus 3 plus 3I. So that cancels. Yeah! So our new equation, this will be the constant term, x squared. So we have x squared minus 2x minus 3 equals 0. We can solve this because it's a quadratic equation. We can factor. We could use a quadratic formula. We could complete this square. We could do so many things. How about we just do one of them? I don't want to do all of them. So I'm just going to do one. Can we factor this? I think so. Negative 3 in the top, negative 2 in the bottom. 3 and 1, and negative 3 is the lead coefficient of 1. So x minus 3 times x plus 1 equals 0. X equals 3 and negative 1. So the roots, I mean, we're solving this. Solving means find all the roots. So all of the roots are 3, negative 1. Can't forget the ones that they gave us. They gave us these. Negative 1 plus I. And then we found by the theorem negative 1 minus I. So those are all the roots. Whew! That was insane. That was a difficult one. Not really, just a lot of steps. For this, we use the theorem. So use the theorem. That was one. Use theorems. Step 2, do synthetic division with the roots that you have. Use synthetic division with your roots. Step 3, it was a quadratic, so solve quadratic. Solve quadratic. The goal in these problems are to reduce it down to a quadratic because we have ways of solving that. So once we can do that, we're home free. We can get the rest of the answers. So that's what we're focusing on. We're trying to bump it down to a quadratic, and then that's what we did. The last thing in this gigantic section that we're doing is Descartes' rule of signs. It's spelled like Descartes, but you say it like Descartes. Like a Jamaican talking about his bobsled. I want to push Descartes. I don't know. So let's see what this says. Let p of x be a simplified polynomial with real coefficients and terms arranged in decreasing degree of x. Great. It's just a polynomial, like we know. The number of positive real roots of p of x equals 0. So the number of real roots is when the equation is equal to 0. Equals the number of variations of sign of p of x, or is fewer than this number by an even integer. What does that mean? We'll see. And then the number of negative real roots of p of x equals 0 equals the number of variations of sign of p of negative x, or is fewer than this number by an even integer. We'll find out what that means. So I'll show you with an example. And this will be example 14. I almost started saying anything. I stopped myself. The instructions for this example, and we will use these rules, will be list the possibilities for the nature of the roots. So the nature of the roots, they mean, are they positive real? Are they negative real? Or are they imaginary? For the equation p of x equals 0.